Hello, Meteorology Lab students, and welcome to your next lab. The next couple labs are going to be looking at what we call synoptic weather symbols, and synoptic basically means at the same time. So this is a collection of weather data that is done around the world and done at the specific times during the day. The idea is that we can get a snapshot of what's happening in the atmosphere globally several times during the day. Now, we collect a lot of data in between those time frames, and that data is also very useful. But we report this data in a very specific format globally, and that's what we're going to look at today, is this format. And the idea with this is we're trying to represent as much weather data as we can in basically as small a space as possible. And the background map here has synoptic weather symbols on it. You can kind of get a sense of just how much data there can be compressed here, and that's what we're going to get into. And so the basic idea is to kind of just run through conceptually what this is. Let's say we wanted to have air pressure on a map. So here we have the United States. We have all these different air pressure measurements. That's great, but there's more to the atmosphere than just air pressure. There's also surface temperature. There's dew point. There's pressure change. How much has the pressure changed in the last 3 hours, something like that. These are all bits of useful information, and you can put them on a map like this, but it's going to get awfully crowded trying to put all this data in the same spot. So what we try to do is try to come up with a way to compact this information into small a space as is reasonably possible, and that's what we have here. So this is an example. It's a generic example of synoptic weather symbols that has all of that information we just saw in the previous maps, plus more, in these very small accumulations of symbols and numbers. And that's what we're going to try to decipher, is what these symbols and numbers mean. So the big thing that's going to help you with this is this sheet here. And what this shows you is an example synoptic weather symbol here. With all of these different numbers and symbols around here. What we're going to focus on today primarily are some of these numbers, a few of the symbols, and really get used to where these things are located. And that's part of the trick of this, is just trying to figure out where is the stuff I'm interested in knowing. And to help you with that, what we have below this from figure 1 in your lab is what each of these mean via some sort of code here. So for example, if you look to the left and above is A, left and above here is this number 77. What does that mean? What is A? So A is temperature. Again, this is just directly from your lab. But other things that we have here, we have different cloud levels. So we have low clouds, we have mid clouds, we have high clouds. We've got pressure, we've got visibility, we've got present weather symbols. Present weather symbols, those will be dealt with in Lab 5, so I'll hold off on those for now. We'll get to those in Lab 5. Cloud cover in 8, so I'll cover that. Our pressure change and tendency. Dew point, another really important one here, is H. Past weather is going to be typically down and to the right. And then our wind speed and wind direction indicator, again, is J here. So a lot of this is, again, relatively straightforward. It's just knowing where to find the information. There are a couple of things I do want to cover that are either really important or a little trickier maybe to kind of figure out. And what I want to start with is sort of my philosophy as to how I think about this and how I learned this. And that is to think about the weather symbol as having sort of the center. And the center is this round circle here, and that is your cloud cover. And it is in eighths. And basically what this is how much of the sky is covered by clouds. And so if it's an open circle, there's nothing in it, no clouds. One little line is 1/8. A little quarter like this is 2/8. That makes sense. 2/8 equals 1/4. Reduce the fraction 2/8, you get 1/4. And then 3/8, 4/8 is half, 5/8, 6/8, 3/4, 7/8 is just a little white line, 8/8 is completely covered, overcast. And then if you see a little extra, that just means the sky is obscured. That could be because of smoke, Could be because of fog. Really smoggy conditions could do that as well, potentially. But something that's preventing you from seeing all the cloud cover would be the sky obscured. But that's that center. And so that's what I like to think about as the center. And then I reference everything as, again, being to the left, to the right, above, below, something relative to that center. So I always like to start with that center, just conceptually in my mind, and then where everything is relative to that center. Another thing I want to cover quickly here is just the wind speed. Wind speed is relatively straightforward. So you're going to have this marker here is going to be wind direction. I'm going to cover that in just a second. But at the end are these little tick marks here. So you have the stick, which tells you wind direction, and then the tick marks on the end tell you the velocity. And again, this is your table 4.1 from your lab, which shows you what these are. Now, generally, I'm going to promote metric stuff for you guys because that's what science is generally done in, is the metric system. This is based on knots. So the easiest way to remember this is with knots. Now, a knot is a nautical mile per hour, and 1 knot is 1.15 statute or regular miles per hour. But just know this is done in knots. And basically, a long tick mark here is 10 knots. A short one is 5. So you'll see those most often. Occasionally, you might come across a triangle. The triangle is 50 knots. And so what you do is you simply add up all of the tick marks that you have. So in this example here, we have a long one, which is 10. We have a short one, which is 5. So a total of 15. Now, again, the table here sort of expands on this, and as does the lab, but just easiest way to think about this is just, again, in 5-knot increments. And again, long is 10, short is 5. So that's the easiest way to think about that. Wind direction. So with wind direction, where the tick mark is sort of pointing, if you want to think of it that way, is the direction the wind is coming from. And we always do this as the direction the wind is coming from. So the standard in meteorology is, if I say it's a north wind, that it is coming from the north. That's what that means. So in this case, it's between south and east, so we'd call this a southeast wind. So the wind is coming from the southeast and going towards the northwest. So just real quick, just to give you some other quick examples. If this was my cloud cover and I had my stick going something like this, that would be between north and west. So that would be a northwest wind at 10 knots. Okay? If it looked something like this, that would be an east wind at 5 knots. Okay? So just think, again, north, south, east, west, and wherever that stick is pointing, that's the direction the wind is coming from. Think of it as sort of like almost like a compass dial. And it's showing you the direction the wind is coming from. Again, can't emphasize that enough. It is the direction the wind is coming from. That's the standard that we use. All right, so that is wind direction and wind speed. Last little bit I want to cover here real quick is pressure. And pressure is going to be to the right and above. Overall, this stuff here is all pressure. This is the pressure tendency in tenths, so it's always in tenths. So this will be 3/10, a drop of 3/10 millibars in the last 3 hours. This indicator here is the pressure tendency. View it like a graph. So this is pressure rising, then falling. And again, there's a table in your handout that shows you quite well what those are, but just view tendency as basically like a little mini graph that you're looking at. Again, in this case, rising, then falling. What I want to focus, though, on is the actual pressure reading here, this number here, because this is a little tricky. There's a little trick you have to do to kind of convert this. Remember that what we're trying to do is put as much information in as small a space as possible. So the way to read this, and you do this for every pressure reading, you do the exact same process, is the following. Take your number, in this case 998, And the first thing you do is you put a decimal point between the last two numbers. And then in the front here, you're going to put either a 9 or a 10 to make this either 999.8 millibars or 1,099.8 millibars. Now, which one do you choose? You choose the one that makes it closest to 1,000. That's the rule of thumb. So you choose the 9 or the 10 that makes it closest to 1,000. In this case, 999.8 millibars. So again, to review, whatever the number is here, these three numbers, whatever it is, put a decimal point between the last two, and then add a 9 or a 10 in front of it to get your actual pressure reading. The reason we do this is because 99.9999999% of all pressure readings you come across are going to be 1,000 and something or 900 and something. And again, the rule of thumb is you use the number that makes it closest to 1,000. That's going to be correct the vast majority of the time. And for the pressure readings we're going to deal with in class, that's going to be correct. Now, again, this is in your handout, but I want to emphasize this too. Do not drop out zeros. This is something that always trips people up. But if, let's say this number here, let's just use a different example. Let's say the three numbers are 0, 1, 0. Do not drop the zeros. A lot of you have tendency to just want to throw zeros out like they're meaningless, like they're valueless. They are placeholders and they are really important. So do not throw out your zeros. Keep them and you do the exact same process. Decimal point between the last two, and I put a 9 or a 10 in front. Think about which one it's going to be. Will it be 901 or 1,001? And again, the one that's going to be closest to 1,000 is going to be putting a 10 in front of that, making it 1,001.0 millibars. So again, we went from 010, we converted that, it ended up being 1,001.0 millibars. So again, do not throw out your zeros. Very, very important. All right, so those are the bits that tend to be a little more confusing or a little harder or involve a little more conversion, something like that. The rest of it, I think, pretty much is pretty well explained in the handout and in the lab materials. Again, you have your cloud symbols here, again, your velocity here, your pressure tendency, all those things that we've talked about. What we didn't get into are the present weather symbols. Fronts we're going to get into a little bit later on as well in different labs. So for now, it's just pretty much focusing on this lab is just where's information that I need? Where's temperature? What is temperature? What is the dew point? What is visibility? What is the pressure? What's the cloud cover? Those sorts of things. That's what we're focusing in on this lab. So check it out. Have any questions, let me know. And I'll see you online soon.